hate it when I get sick and don't feel well, but I'm so thankful that there was medicine out there that can make you feel better. Everything that goes into medicine is made up of chemicals. This is Paula Garcia Todd. She is my mom and she works at DuPont. She's going to explain all the chemistry used in pharmaceuticals.
Hi, my name is Paula Garcia Todd and I work in pharmaceuticals. There is a great deal of chemistry that goes into making a pharmaceutical. Pharmaceutical scientists spend a lot of time looking for compounds that are going to have a beneficial effect in your body in fighting a disease. And it can take many years to get to this. So the usual process takes about 10 to 15 years in clinical trials and research and development to get a product from the very beginning to the end product that you see on the shelf in your pharmacy. Did you know that out of every 10,000 compounds that are screened, only one becomes an actual medicine that you find in your pharmacy? So it takes a great deal of time and it takes a lot of molecules to find the right product. Once you have a chemical compound that's identified as being helpful to fight a disease, it is then referred to as an API, which stands for Active Pharmaceutical Ingredient. But what a lot of people don't realize is that outside of the API, there's a lot of other chemistry that goes into your medicine. So when you take a tablet or a capsule or even a liquid formulation, there's the API that's found in there, but there are a bunch of other ingredients that go in there too. There could be fillers to help bulk up the tablet so it's a nice size that you can swallow it. There could be sweetening agents to help if the API has a bitter taste to it. There could be a coating that's added to it that allows it to make it easier to swallow. And then if there's any medication that you only take once or twice a day, it's very likely that it has a controlled release polymer in it. What does that mean? So polymers are really long molecular chains. You can think of them like a bunch of spaghetti string that's all intertwined together. And all of these spaghetti strings, or these polymers, are crunched down together to make this tablet along, intermixed with your API. And once you take this tablet and, it hits your stomach, the tablet actually starts to swell. And it starts to loosen up all of these spaghetti strands, and it allows the API to come out of the tablet at a very slow rate, hence the controlled release effect. So what that means is that when you take the tablet, instead of it being dissolved and absorbed in your body in a typical 4 to 6 hours, sometimes it can be in your body for 12 to 24 hours thanks to these polymers. So that's how that works. But outside of solid formulations like tablets and capsules, you also have liquid formulations. And again, these also have the API in them, but they have a bunch of other things in them too, like the sweetening agent. But these things also have something really cool in them called hydrocolloids. Hydrocolloids are what keeps the medicine from just sinking to the bottom of your bottle all the time. Now, it is still recommended that you shake before you take something, but hydrocolloids can certainly help ensure that the medicine is well dispersed instead of all the way to the bottom of the bottle. So I hope you learned a little bit about how chemistry is important in pharmaceuticals and how chemistry helps you feel better. So I hope you guys have a great chemistry week. Take care.
Thanks for explaining this, Mom. This really shows how chemistry is everywhere when it comes to helping sick people.